our last couple of examples, we will be introducing a new method to solve quadratic equations, and that method is the square root method. So notice that in example 9, they give us this equation here, but then right under that, I give you another equation. These two equations are the exact same equation, they're just written in different forms. Later on in this course, we will talk about how to go from this form of a quadratic to this form of a quadratic. And the process to get there is called completing the square. But we are not going to learn about how to complete the square in this lesson. What I want to talk about is if I give you a quadratic equation that just looks like this, where you already have a term that is squared, how you can solve that equation without computing the discriminant, without using the quadratic formula or anything like that. So everything that's highlighted in that equation right now, I'm going to try to isolate that right now, because if I can get the thing that's squared by itself, then I can square root both sides and do plus or minus to continue solving the equation. So to get that highlighted part by itself, I'm going to first add 10 to both sides of the equation. This feels like a good time to mention. Sometimes I hear people say, oh, let's divide everything by 2, or divide by 2 first. It's okay to divide by 2 first if you divide everything by 2. So what I commonly see people do is they'll divide by 2 here and divide by 2 here, which is problematic because they did not also divide the 10 by 2. So if you're going to divide by 2 first, make sure you're dividing everything by 2 first. But I'm not going to do that. I'm going to just add 10 to both sides of the equation first. As 2 times x minus 4 squared is equal to 10. Now I will divide both sides of this equation by 2, which gives me that x minus 4 squared is equal to 5. Now that I have the x minus 4 squared by itself, I'm ready to introduce the square root to both sides of the equation, and I'll put a plus or minus in front of the square root. The x minus 4, well, the square root and the square will cancel each other out and just leave us with x minus 4 on the left side of the equation. And then on the other side of the equation, we just have plus or minus root 5. I want to emphasize that this is 2 separate equations. I think, yeah, that's how we'll do it. We'll break it up into 2 separate equations. There's one equation where it's equal to a positive root 5. That's the plus. And then there's another equation where it's equal to the negative root 5. That's the minus. And now I will solve both of these equations by adding 4 to both sides. So I get x is equal to 4 plus root 5. And I'll add 4 here to get that x is equal to 4 minus root 5. And those are the 2 solutions to those equations. So again, this is called the square root method, and it works when you are solving a quadratic equation that is already in this form where it has something squared. Notice there is no x term that is in there. So what I mean by no x term is there's no term that just has a single x in it with no exponent on it. Believe it or not, we actually have already talked about the square root method. We used the square root method earlier back in example 5. So over here, when I isolated the x squared and square rooted both sides of the equation and used plus or minus, that was another example of the square root method. Now let's go on to number 10. Once again, I have given the equation in 2 separate forms. We're going to work with the second version of the equation, the one that has the x plus 4 squared in it. We're going to begin by isolating the entire term that is squared, that x plus 4 squared. Once we have that by itself, then we'll square root both sides. So we'll start by adding 6 to both sides of the equation. So I have negative 3 times x plus 4 squared is equal to 6. And now I will divide both sides of this equation by negative 3. So I'm left with x plus 4 squared is equal to a negative 2. Square root both sides. I'm going to just move this negative 2 over so I have room to put the square root. So square rooting both sides, when we do square root, we need to make sure we're doing plus or minus. The squared and the square root cancel out and just leave us with x plus 4 on the left side of the equation. And on the right side of the equation, we have that plus or minus the square root of negative 2. Because it is a negative number under that square root, we are talking about an imaginary number here, a complex solution, because it can't be a real number because we cannot take square roots of negative numbers. So because it's imaginary, I'm going to go ahead and pull the I out, and I still just keep the 2 under that square root. Now we're going to go ahead and continue solving for x. I will break this up into 2 separate equations. I will write one equation with the positive I root 2, or you could write it as root 2i. My concern with that, if you're going to write the root 2 in the front, it should be clear when I look at it that the I is not under the radical. So what I would not want is you write root 2i and it looks like that, because this I is definitely under that square root. So I'm just going to keep the I in the front to make it clear that the I is not under the square root. So that's the equation with the plus. Now I'll write the equation with the minus. And we'll go on and solve both of these equations by subtracting 4 from both sides. So minus 4, we get x is equal to I root 2 minus 4. That's one of our solutions. Minus 4, we get x is equal to I root 2, I dropped the negative in front of the I. Negative I root 2 minus 4.